The goal of our project is to create a visual display that could supplement or possibly replace the current audio output of the Cetacean Hearing and Telemetry, or CHAT system. The CHAT system is being developed by the Contextual Computing Group, led by Dr. Thad Starner. This dolphin translation system was developed to enable marine biologists from the Wild Dolphin Project to record the behaviors of wild dolphins more effectively. Through this research, they hope to gain a better understanding of the dolphin language, as well as gain insight into the cognitive processes of creatures whose mental capabilities may be similar to our own. When designing the device, we interviewed the researchers currently working on the CHAT system to understand the conditions under which the display will be operating. Here you can see what features were included in this iteration of the project. The display is divided into two halves. The right half is for the output of the translation system, and the left half is for the recognized dolphin calls, also known as the input. The input side also contains an arrow that will indicate the location of the dolphin that is communicating. Each side of the display is also able to show the three-letter codes that are used to identify either specific dolphins, researchers, or objects that the researchers are using during the interaction. Currently, numbers representing rows and the words in and out are used on the display, but they will not be present in later iterations. To begin constructing the device, an acrylic enclosure was fabricated to closely contain the LED display and its components. Once the pieces were cut to size, they were glued together and then sealed with a clear silicone-based sealant. The entire enclosure, with the exception of the acrylic viewing window, was then encased in 30-minute slow cure epoxy. This was then coated in 2 layers of black plastidip to minimize glare from the sun, as well as any additional internal reflections. The brace for the display was also fabricated from acrylic and used Velcro to attach itself to the dive mask. With a small adjustment to the code, the display allows viewing from multiple angles and distances. Additionally, code was added to allow the display to be flipped, so that it can be placed on the top or bottom of the mask. The first requirement that we tested was waterproofing. To prove that the new enclosure was indeed waterproof, we went to an indoor pool. The test consisted of checking the dive mask's functionality, and checking the functionality while underwater, and checking it one final time outside of water. After the test, we concluded that the enclosure was waterproof. Because our device is going to be used in the intense sun conditions of the Bahamas, the display must also have adequate brightness and contrast while in bright water. In order to test this, we took the device to an outdoor pool on a very sunny day. As you can see, the display is still easily readable in the bright water. Our final test was conducted in Florida. The enclosure was found to be waterproof in salt water to a depth of at least 12 feet for over 5 minutes. In conclusion, the device has met all the major requirements of the research team and should be considered for future utilization.